advances in space exploration, humanity has recently invested significant time and money in technologies that could enable efficient use of space resources. Leading these efforts is a potentially historic exploration where Earthlings could extract oxygen on the Moon. Come from the satellite. In October 2021, the Australian Space Agency and NASA signed an agreement to launch an Australian-made rover to the Moon. Under the U.S. Artemis program, aiming to collect lunar rocks to find types that could provide and extract breathable oxygen on the Moon. Although the Moon has an atmosphere, it's very thin and composed mainly of hydrogen, neon, and argon. It's not the gas mixture that can sustain life for oxygen-dependent mammals like humans. There's plenty of oxygen on the Moon. So if we can extract oxygen from regolith, would it be enough to support human life on the Moon? Oxygen can be found in many minerals in the ground around us, and the Moon is mostly made of similar rocks. Like those found on Earth, though with a slightly higher amount of material from meteorites. Minerals such as silica, aluminum, iron, and magnesium dominate the lunar landscape. All these minerals contain oxygen, but not in a form accessible to our lungs. On the Moon, these minerals exist in various forms, including hard rock, dust, gravel, and surface rocks. This material results from intense impacts of meteorites hitting the lunar surface over countless millennia. Some call the Moon's surface layer soil, but some scientists hesitate to use that term. Soil as we know it is quite miraculous, occurring only on Earth. It was created by a series of organisms working on the soil's parent material, regolith derived from hard rock over millions of years. This results in a matrix of minerals not present in the original rock. This soil has remarkable physical, chemical, and biological properties, whereas the material on the Moon. So how do we extract oxygen on the Moon? Lunar regolith is composed of about 45% oxygen, but that oxygen is tightly bound to the minerals mentioned. To break those strong bonds, we need to put in effort. You might be familiar with this if you know about electrolysis. On Earth, this process is commonly used in manufacturing, such as in aluminum production. An electric current is passed through a liquid form of aluminum oxide, often called alumina, via electrodes to separate alumina from oxygen. In this case, oxygen is produced as a byproduct. On the Moon, oxygen would be the primary product, and the extracted aluminum or other metal would be a potentially useful byproduct. That's a fairly simple process, but the catch is that to be sustainable, it needs to be supported by solar energy or other energy sources available on the Moon. Extracting oxygen from regolith would also require significant industrial equipment. First, we need to convert solid metal oxides into a liquid form by applying heat or combining heat with solvents or electrolytes. We have the technology to do this on Earth, but moving this machinery to the Moon and generating enough energy to operate it will be a major challenge. In early 2021, a Belgium-based space application services startup Space Application Services announced it was building 3 experimental reactors to improve the oxygen production process. They plan to send the technology to the Moon by 2025 under the European Space Agency's ESA in situ resource utilization mission. According to ESA, they are currently preparing a lunar surface mission to demonstrate the technologies needed for in situ resource utilization on the Moon. The goal of this in situ resource utilization mission is to make water or oxygen production on the Moon feasible by 2025. Various processes and techniques have been developed to extract chemically bound oxygen from lunar regolith. The mission not only supplies the crew, Oxygen and hydrogen produced on the moon could also be used as fuel for missions further into the solar system, such as to Mars. While transporting oxygen from Earth is efficient for short space trips or budget-friendly missions, in situ produced oxygen is crucial for long-term human habitation on any celestial body. The leftover alloys after oxygen extraction won't be wasted. In the future, these alloys could be used to build lunar or Martian bases using 3D printing technology. Human ability to stay long-term on the moon would significantly reduce the cost of deep space exploration missions, mainly due to the moon's low gravity and lack of atmosphere, making spacecraft launches much easier than from Earth. The most important question is how much oxygen is actually on the moon. If Earth's oxygen extraction technology is successfully brought to the moon, it would revolutionize human space exploration, as the moon could then truly provide breathable air for humans. So, how much oxygen does the moon have? If we ignore oxygen bound in deeper hard rock material and only consider extractable regolith easily accessible on the surface, we can make an estimate. Each cubic meter of the moon averages 1.4 tons of minerals, containing about 630 kilograms of oxygen. NASA states that humans need to breathe about 800 grams of oxygen per day to survive, so 630 kilograms of oxygen would keep one person alive for about 2 years or more. Now, if the average depth of regolith on the moon is about 10 meters and we can extract all oxygen from it, that means the top 10 meters of the moon's surface would provide enough oxygen to support all 8 billion people on Earth for about 100,000 years. This number is truly amazing. And of course, this also depends on the efficiency of managing the extraction and use of oxygen on the moon. Thank you for watching. If you enjoyed the video, don't forget to like and subscribe to the Hidden_Realms channel to catch the latest videos. Hello and see you again. Subscribe to the Guia Nigo channel so you don't miss out on exciting videos.